So if you build a flawless, millimeter accurate map of city's power grid, but you forget to include a single seemingly boring text file attached to it,
Right.
well, in the eyes of the U.S. federal government, that data essentially does not exist.
It just becomes a total phantom data set.
Wow.
Completely invisible to their search portals, impossible to verify, and honestly just far too risky for any civil engineer to actually use.
Welcome to the deep dive. Today we have a highly specific, very critical mission for you. We are conquering Section 206 of the GISP.
The Geospatial Information System's professional exam.
Exactly. And if you are prepping for the GISP right now, you already know that Section 206 focuses entirely on one single topic, which is metadata.
Right. The definitive instruction manual for your data. The
Yeah.
who, what, when, where, why, and how.
Yeah.
We're really looking at the absolute foundation of data management today.
Now, I want to address the elephant in the room right off the bat here. If you work in GIS, you've probably heard the jokes.
Oh, absolutely.
I mean, the study materials we're looking at today even point out that metadata creation is widely dubbed the most boring task in the industry.
It's true.
There is literally a metadata song floating around out there on the internet that analysts play just to find the motivation to grind through the data entry.
It definitely carries a reputation. I mean, it's often treated like the tedious paperwork you're forced to do after the fun part is over.
Right after making the map.
Yeah, after making the map or, running the statistical analysis. It's like the chore at the end.
But we are going to completely flip that narrative today because metadata isn't just bureaucratic paperwork.
Not at all.
You really have to think of it less like a grocery store barcode and more like the VIN, the vehicle identification number, combined with a massive Carfax report for a used car.
That's a great way to put it.
Right. Because a data set without metadata is like buying a Ferrari off Craigslist with no title, no history, and no proof it wasn't submerged in a flood last year.
Yeah, you might think you're getting a great deal, but you cannot legally or safely drive it.
Exactly.
Yeah.
So simply put, metadata is data about data.
And the core mechanic here really is transparency.
Right.
For the exam, you aren't just memorizing dry definitions. You are learning the underlying mechanics that allow data to be shared across, completely different systems, organizations, and applications.
It goes with Adam.
Without metadata, interoperability is impossible. You just have isolated silos of geometry on a screen that literally no one else can confidently interpret.
Okay, so let's unpack this. In the GIS world, there's this concept called the 3Ds of metadata. The exam study guides really hammer this home for you.
They do.
Your metadata must be detailed, it must be dependable, and it must be well documented.
Right.
But if metadata is our Carfax report, what are we actually looking at under the hood? Like, walk us through the core anatomy of a metadata record.
Sure.
Let's say I open up a file right now. It's the very first thing I see.
So the first major section is identification. This is your brief narrative, the high-level summary of the dataset's purpose. It always includes a title. And for professional data, that title needs to be incredibly specific. So instead of calling a file, map final version 2.
We've all been there.
Right. The title would be something like 2023 land cover for Cook County, IL.
Got it. It sets the boundaries immediately.
Exactly. And alongside the title is the abstract, which is a brief summary of the contents.
Okay.
It might read, this layer depicts generalized land cover derived from NAIP imagery.
Let me stop you there for a second because we want to make sure every term makes sense for anyone listening who might be a bit newer to the field.
Yeah.
NAIP imagery, what exactly is that?
Good catch. NAIP stands for the National Agriculture Imagery Program.
Okay.
It's this massive federal project where planes fly over the continental United States during the agricultural growing seasons, capturing incredibly high-resolution aerial photography.
Oh, wow.
Yeah, so if a metadata abstract mentions NAIP, it's telling the user, hey, we built this map by tracing over those specific high-quality government airplane photos.
Got it. It tells you the raw ingredients, basically.
Exactly.
I also saw that the identification section includes keywords. In the age of Google, I assume that's mostly just for search engines.
It is, but it's highly structured. Keywords help people discover the data using predefined taxonomies.
Okay, meaning what?
Meaning, if someone goes to a government data portal and searches for wetlands, your map of marsh habitats won't show up unless the word wetlands is baked into your keywords.
I see.
Yeah, it creates a bridge between different vocabularies.
Okay, so identification is basically the cover of our book.
Yeah.
But let's say I pull that NAIP-derived land cover data, and I notice a massive error.
Like what?
Like an entire neighborhood is misclassified as a lake. Telling me what the data is doesn't really help me fix it. Who do I hold accountable for that?
That brings us straight to the contact section.
Okay.
This outlines the people or organizations actually behind the data. And for the GISP exam, pay very close attention to the 3 distinct entities usually listed here.
Right. The study guide breaks these down.
Yeah. First, you have the originator. This is the person or agency who actually developed the raw data set.
Okay.
Then you have the publisher, who assisted in producing and finalizing the end product. And finally, you have the distributor.
I imagine the distributor is just the storefront, like an open data website.
Essentially, yeah. The originator might be, say, the Illinois Department of Natural Resources. They actually went out and mapped the data.
Right.
But the distributor might just be a state clearinghouse website whose only job is to host the download link.
Gotcha.
So if you find that lake error you mentioned, the contact section tells you not to bother the distributor, but to email the originator directly to report the flaw.
That makes total sense. Now, obviously, this is geospatial data, so the geography itself has to be defined.
Right.
The sources talk about spatial reference and entities. What does that actually look like to a human reading the metadata file?
Well, for geographic extent, you will typically see a bounding box.
A bounding box.
Yeah, it creates a digital geofence by listing the extreme limits of the data. It will literally say, bounding box west, Nanick 88.3 east, Nanick 87.5 north, 42.2 south, 41.4.
So it just draws this invisible box around your data on the globe.
Exactly.
That way a software program can instantly know, hey, this data doesn't cover New York. Don't even bother loading it.
Exactly. It saves massive amounts of computing power and time for the end user.
Right.
But beyond the bounding box, the spatial reference section also defines your coordinate system. It will specify something hyper-exact like NAD 1983 State Plane, Illinois East, FIPS 1,201 feet.
Oh, okay. That is quite the mouthful.
It is.
Why can't we just say Chicago, measured in meters? Why do we need that intense level of mathematical jargon?
Because the Earth isn't a perfect sphere.
Okay.
It's kind of a lumpy, irregular potato shape.
A lumpy potatoes. Nice.
Yeah. And if you try to wrap a flat piece of graph paper around a lumpy potato, it's going to tear and distort. So geodesists create mathematical models called datums, like NAD 1983, which is the North American datum of 1983.
Okay.
It essentially smooths out the math for that specific part of the globe. If you take my map, which was built using the NAD 1983 math, and you load it into a project that assumes a completely different mathematical model, your map might physically shift by hundreds of feet.
Which would be disastrous if you're trying to dig a trench to avoid hitting a gas line, for example.
It's completely disastrous.
So the metadata acts as a failsafe, forcing the software to align the math before rendering the map.
It's a critical safety mechanism.
Yeah.
And finally, under the basic anatomy, we have temporal extent.
Because time is just as important as space.
Oh, absolutely.
I've definitely downloaded data sets that look perfect until I realized, the roads were mapped 20 years ago and my neighborhood didn't even exist yet.
Right, and temporal extent focuses on exactly those time-related characteristics, but it's not just a single date of creation.
What else is there?
A robust metadata record tells you the time period the data is actually considered valid, and crucially, its update frequency.
Like how often they refresh it.
Exactly. Is this dataset refreshed daily, weekly, or annually?
Knowing what is in a data set is one thing, but this kind of transitions us into a slightly different area.
How so?
Well, how do we know if it's accurate or if we're even legally allowed to use it? We're moving from basic identification into actual data stewardship now.
We are.
But let me push back on this for a second, just to play devil's advocate for you listening. Is all this intense detail really necessary? For an analyst just trying to make a quick, simple map for a Tuesday morning presentation, filling out bounding boxes and update frequencies, feels like a lot of, bureaucratic overkill.
What's fascinating here is that we often view our data through the lens of our immediate local needs, like that Tuesday presentation.
Right, just getting the job done.
But metadata is about supporting the entire life cycle of data creation, management, and access on a macro scale. Without this supposed bureaucracy, our national geospatial infrastructure collapses.
Collapses? I mean, how so?
Think about platforms like geoplatform.gov in the U.S., which aggregates data from dozens of federal agencies.
Okay.
That website doesn't actually store petabytes of heavy, massive map files. It scrapes and reads the metadata.
Oh, wow.
Yeah, Executive Order 112906 and OMB Circular A16 are federal mandates requiring agencies to maintain metadata for exactly this reason.
So it's legally required for them.
Exactly. When emergency responders are dealing with a hurricane, they don't have time to call the local county office to ask if a flood zone map is current.
Right.
The metadata is the only thing standing between coordinated disaster response and total chaos.
Okay, so it's less about my Tuesday presentation and much more about ensuring the grid of shared geographic knowledge functions on a systemic level.
And that systemic function relies entirely on trust. Let's look at the trust elements in a metadata record, starting with lineage.
Okay.
For the GISP exam, this is a heavy hitter concept. Lineage is essentially the dataset's historical track record.
This is our Carfax report.
Exactly like the Carfax. Lineage describes the exact sequence of operations applied to the dataset from the moment it was born.
Okay.
It logs any data transformations, projection changes, or spatial aggregations. If a 1970 paper map was scanned, digitized into a computer, and then run through a smoothing algorithm, every single one of those steps should be in the lineage.
So if I'm looking at a map of a protected wetland, the lineage tells me if an actual human being went out in rubber boots and verified those boundaries in the field, or if an AI algorithm just guessed based on satellite imagery.
Yeah.
That fundamentally changes how much I trust the data.
It completely alters your risk assessment. And speaking of risk, that ties directly into the quality section of the metadata.
Right, quality.
Quality evaluates the accuracy and the standards the dataset followed. For the exam, make sure you can differentiate between horizontal accuracy and vertical accuracy.
Okay, I'll take a swing at this. So horizontal in your ground position.
Yeah.
Your X and Y coordinates on a flat map, and vertical is your Z coordinate, meaning your altitude or elevation.
You got it perfectly. And vertical accuracy only comes into play if you actually have altitude data present, like in a 3D topographic map.
Makes sense.
The quality section also evaluates completeness, like did they map all the roads or just the highways, and any logical consistency checks the data went through.
Okay, so we've tracked its history with lineage, and we've verified its precision with quality. What about the rules for actually using it?
Yeah.
Because the study guide explicitly mentions legal constraints.
The legal and access constraints section is vital, especially regarding liability. You will frequently see a use constraint that clearly states, for planning purposes only, not for navigation.
Oh, that is a massive legal shield.
It really is.
If you use a generalized planning map to navigate a boat through a harbor and you crash into a reef, the metadata essentially protects the originator from a lawsuit because they told you it wasn't accurate enough for navigation.
It serves as a binding disclaimer. It also handles access classification.
Okay, like security.
Yeah, you can't just share everything openly on the internet. Sometimes data contains the locations of endangered species habitats or protected archaeological sites.
Oh, right.
If that data is public, poachers or looters can use it. The metadata is the mechanism that tells a server, restrict this data, government agency use only.
Now, here's where it gets really interesting. If metadata is about universal trust, and it's what allows a server in Washington, D.C. to talk to a server in California, then everyone needs to be speaking the exact same structural language.
Right.
But the source materials provided for this deep dive list, an absolute alphabet soup of standards. I mean, we're talking ISO, FGDC, Inspire, Dublin Core.
Yeah, it's a lot.
For the professional listening right now who just wants to pass the GISP exam, how do they navigate this? Like, why are there so many?
Let's synthesize the heavyweights for you. You absolutely have to know the FGDC CSDGM.
Try saying that 10 times fast.
Right. It stands for the Federal Geographic Data Committee's Content Standard for Digital Geospatial Metadata.
Okay.
This is the legacy U.S. standard, established way back in 1998. It is incredibly rigid and comprehensive, containing 10 specific sections of information.
Wow.
For a long time, if you wanted to submit data to the U.S. government, it had to be in this exact FGDC format.
But 1998 is ancient history in tech years. What's the modern standard?
The modern global heavyweight is ISO 19115.
ISO 19115.
Created by the International Organization for Standardization. The key difference here, and this is a great point for the exam, is that ISO is modular.
Meaning you can snap different pieces together like Legos.
Exactly. FGDC was one massive monolithic template. ISO 19115 allows you to attach specific extensions only when you need them.
Oh, nice.
If you're documenting basic city parks, you just use the core standard. But if you're suddenly documenting complex satellite imagery, you snap on the imager module without breaking the core file.
That's super efficient.
It's so effective that even the US FGDC now officially recommends organizations transition away from their 1998 standard and adopt ISO.
Okay, so ISO 19115 is the flexible global standard. What about Inspire?
Inspire is used by European Union member states.
Okay.
Before Inspire, a forest fire crossing the border from Spain to France would hit a digital wall because their emergency management systems used entirely different data standards.
Wow, so they couldn't even share the map of the fire.
Right. Inspire is built on the ISO framework, but it adds strict policy-driven rules to harmonize data across borders. It mandates specific standards for 34 distinct spatial data themes.
34 themes specifically designed so European nations can actually talk to each other during cross-border projects.
Yes.
That leaves one outlier I saw in our notes, Dublin Core. It seems entirely different from the others.
If we connect this to the bigger picture of the web, Dublin Core is your lightweight cross-domain standard. It wasn't built just for maps.
Oh, no.
Yeah, it only has 15 basic generic fields, things like title, creator, date, and format. It doesn't care if the file is a GIS shapefile, a PDF document, or an MP4 video.
Because it's so simple, I imagine web search engines and digital libraries absolutely love it.
They do.
They can scrape millions of files incredibly fast because they don't have to parse through complex bounding boxes or lineage histories.
Precisely. It sacrifices deep spatial detail for broad, rapid discoverability on the web.
Okay, so we have these different frameworks, FGDC for legacy US data, ISO 19115 for modern global work, Inspire for Europe, and Dublin Core for lightweight web indexing.
Right.
But under the hood, this is all just machine-readable code, right? The sources point out that GIS metadata is ultimately delivered as an XML file.
Extensible markup language, yes.
Okay.
Any basic text editor like Notepad can open an XML file. It relies on specific tags to structure the information so a computer program can parse it instantly.
I was looking at an example earlier. You open this file, and it just looks like brackets. You might see an open tag that says origin, followed by the words National Aeronautics and Space Administration, and then a closing tag with origin again.
Exactly.
You're just wrapping the human-readable text in these tiny labeled folders so the software knows exactly where to look.
Every single standard we just discussed, FGDC, ISO, is just a different set of rules for how those XML tags should be named and organized.
Which makes me think, if I have a massive library of legacy FGDC metadata from 1999, and I want to upload it to a modern ISO 19115 web portal,
Yeah.
I really don't want to manually retype thousands of text files. I know tools like Esri's metadata translator exist. You just hit a button, right?
Well, you can, but you have to be incredibly careful. This is a major pitfall in daily GIS work.
Why?
When you use an automated tool to translate XML from one standard to another, it matches the tags. But if a highly specific field exists in your old FGDC file, and there is no exact equivalent tag in the new ISO schema,
The machine gets confused.
no, that information doesn't just find a temporary home. By default, the translator simply drops it.
Wait, it just deletes it permanently?
It vanishes.
Oh,
If you aren't paying attention, you could translate an agency's entire historical archive and accidentally wipe out a critical piece of lineage or a vital legal constraint just because the new XML schema didn't have a matching bucket for it.
that is terrifying. And a massive pro tip to remember for the exam and real life. You cannot treat metadata conversion as a totally automated, thoughtless process. You have to audit what the machine is doing.
It absolutely requires human stewardship.
So what does this all mean? We've covered a tremendous amount of ground today. We completely ditched the grocery label analogy and realized metadata is the VIN and Carfax of our spatial data.
Right.
We explored the 3 Ds, detailed, dependable, well-documented. We walked through the anatomy from bounding boxes and datums to the changelog of lineage. And we navigated the alphabet soup of FGDC, ISO 19115, and lightweight Dublin Core. For you listening and prepping for Section 206 of the GISP exam right now, how do we synthesize all of this?
The absolute best way to synthesize this is to look at the official sample question provided by the GIS Certification Institute.
Okay, let's hear it.
The question asks simply, what is the purpose of GIS metadata?
It seems almost absurdly simple after dissecting XML translations and European border data.
But the exact phrasing of the answer is what they want you to know. The correct exam answer is to provide a detailed description of the data, including its title, abstract, and keywords.
Ah, okay.
As the source material explicitly notes, it serves as the instruction manual for understanding how the data was created, making it essential for proper data management.
It is the instruction manual. If you remember nothing else from this deep dive, remember that. And if you were listening to this while studying, we wish you the absolute best of luck on Section 206. I know the metadata song exists because this topic can feel dry. But you aren't just memorizing definitions, you are mastering the foundation of data integrity.
This raises an important question, though, something for you to consider long after the exam is over.
What's that?
We are currently entering a wild era of GIS where automated mapping, AI-generated datasets, and massive web scraping are becoming the absolute norm.
Yeah, they're everywhere.
The sheer volume of spatial data is exploding. So in that chaotic environment, will the painstaking, deliberate human act of writing metadata, carefully outlining the lineage, the mathematical datums, and the legal liability constraints be the only thing that separates a highly trusted professional geographic system from a sea of completely unreliable digital noise?
The Carfax report versus a flood-damaged car.
Mhm.
Next time you sit down to fill out an XML file, remember you aren't just doing paperwork. You're building the trust that holds our entire geographic infrastructure together. Good luck on the GISP exam.